So let's practice solving equations. So in this first one, x is on both sides. So I like to get rid of the x's where they're fewer and get a positive coefficient for x, a positive 3x there, equals negative 11. Add 5 to both sides. 3x equals negative 6. Divide by 3. X equals negative 2, right? That's the one number that will make that equation true. And the second one, they're on the same side, so we're combining like terms. 6x equals 30. Divide by 6, x equals 5. Okay, so we reminded you how to solve a basic equation. Now, what does it say here? It says yes or no, if x equals b and x equals c, right? B and c are both equal to the same thing, x, right? And x has to be the same number when you're talking about the same problem. Does that mean b equals c? And the answer to that is yes, okay? And we're going to use that today. Because if b equals this and c equals this, they do have to equal each other. Okay, so in 6.1, we learned to graph these two lines. There's the blue one is y equals 3x, right? It has a y-intercept of 0, 0, and a slope of 3. The red one has a y-intercept of 0, negative 5, and a slope of negative 2 down 2 over 1. You graph them, and we found this point, and the solution to this, the one combination of x and y that makes them both true, is what? X is negative 1, y is negative 3, negative 1, 3. So can we do that without the graph? Yes, and there's multiple methods of doing it. We're going to use a method called substitution. And that's what that question at the end of the warm-up was about. All right, so what did we learn in the last unit? We're trying to find where the one spot where the two equations are equal, where the two equations have the exact same x and y, where x and y are exactly the same on both equations, right? Each equation, each line has an infinite amount of combinations of x and y, but there's only one combination where they're both the same. So what can we do with that? Well, look at these two equations. We have y equals negative 2x plus 5 and y equals 3x. We can substitute or replace, right? What is a substitute teacher? All right, a substitute teacher is the one who replaces me when I'm not there. And that's the same thing we're going to do. Since this negative 2x plus 5 equals that y, it also has to equal that y, right? Because we're looking for where these y's are the same. So that's what we're going to do. So we're going to write negative 2x plus 5, and we're going to substitute that in the second equation, which equals 3x. Now let's solve that equation. Okay, go pause the video and do that. So hopefully you added 2x to both sides. You got 5 equals 5x. Divide both sides by 5. 1 equals x. Now, that's not the answer, right? We're finding a point where they cross. So we now know the x coordinate is 1. We're not done. You can take that 1 and put it in either of those equations and figure out why. Well, usually one of them is easier than the other, and that's certainly true there. So in that second one, it says y always equals 3 times whatever x is. Y equals 3 times 1. So it turns out when x equals 1, y equals 3. Now that's all you would do, and that's how you do your homework. You find the point, in this case 1, 3, that makes both equations true through substitution. Now a couple of things. I could have put it in the top one, and you would have gotten y equals negative 2 times 1, x was 1, plus 5. You still get 3. Either way, right? You're looking for the one place where the x and y coordinates are both the same. So I substituted negative 2x plus 5 into the red one. Could I have substituted the 3x into the blue one? Yes, it's exactly the same equation, just everything is flipped around. Okay, so let's try another one. Oh, before we try another one, there is the actual way to do it with graphing, right? The blue one had the y-intercept 0, 5, slope of negative 2. The red one had y-intercept of 0, 0, slope of 3. And there's that one point where they intersect, 1, 3. Okay. Hopefully you can see that substitution, once you practice it, will be faster and probably more accurate than drawing a graph. So let's try this. So you can do it either way, but I'm going to substitute that negative 3x plus 9. Since it equals this y, it also we're looking for the spot where it equals the other y. So you substitute that in, you replace that. Now solve that equation that has x on both sides. Hopefully you're adding 3x to both sides, because I always like to get a positive x. So 9 equals 5x minus 21. Add 21 to both sides. 30 equals 5x. Divide by 5 both sides. So the x coordinate is going to be 6, right? So I can put 6 in either one of those. I'm going to put it in the bottom one. It's 2 times 6 minus 21. So we get 18 minus 21, which is negative 3. And so the solution where these two things cross is at 6, negative 3. So now we're going to do this for a real world situation. So what does it say? It says 2 trees were planted at the same time. A spruce tree was 20 feet tall when it was planted and grows 4 feet per year. All right, so let's call that S for spruce. All right. The spruce tree was 20 feet tall when it's planted, so that's its y-intercept, and grows 4 feet every year. So 4y plus 20 describes the spruce tree. And a fir tree was 4 feet tall when it was planted and grows 8 feet per year. So that's the equation of that. Now in a previous lesson, we graphed these, right, and saw where they cross. So let's just show you that. All right, the blue one, right, starts at 0, 4. So it was at 4 feet and grew 2 boxes, and each box is worth 4, so it grew 8 feet every year. The spruce tree started at 20 feet, right? These are going up by 4s. So it started at 0, 20, and went up 1 box, which is 4 feet per year. And the solution is what? At 4 years, they were both 36 feet, okay? So now let's see if we can get that with substitution. So we're going to put that into here. 4y plus 20 equals 8y plus 4. And let's solve that. So I'm going to subtract 4y from both sides. So I get a positive coefficient there. Subtract 4 from both sides. 16 equals 4y. Divide by 4. Y equals 4. Now, y is the first coordinate here, right? Because what's y for years here? It's actually the x coordinate, which is confusing. All right. Now, to figure out how tall they were at year 4. So we know from that, year 4 was the year they were both the same height. Right? The blue one, which was the fir tree, started smaller but grows faster and caught up. So now we put it into either one. I'll use F. All right, equals 8 times 4 plus 4, 32 plus 4. Yeah, both of these equations say that at 4 they were 36 feet tall. Substitution. So let's do this one. So the tricks we learned at the beginning of the year, still going to be useful. Now, we could add 2/3 x to both sides. That would actually work pretty well here in this particular case. But let's clear our fractions, right? We're going to multiply both entire sides by 3, distribute that 3. This cancels out. You get 1xx minus 21. These cancel out. You get minus 2x minus 12. All right, I'm going to get my positive. Whoops, I'm thinking about the answer. Plus 2x, both sides. 3x minus 21 equals negative 12. Add 21 to both sides. 3x, that's sort of always tricky. 9, I believe. And so the x coordinate is 3. So now I got to put it in one of those to get the y coordinate. And do not forget this part of the test. There will be someone here who does. These cancel out, and you get y equals 1 minus 7, which is negative 6. So the solution to this, where they intersect, is at 3, negative 6. Right? Clearing fractions. Okay, so the equations up until now were both in slope-intercept. Now look at this. The top one's in slope-intercept, the bottom one's in standard. But it's the same trick, it just looks a little different, right? If it equals that y, it equals that y. So you're going to write the second equation, but you're going to replace or substitute that plus y with minus 3x minus 16. Now, by the way, I could have written this plus negative in parentheses, but you would just be distributing a positive 1 there. That's what's going on there. I replaced that plus y with negative 3x minus 16. And so that equals 12. That's my equation. I combine my like terms. 4x minus 16 equals 12. I add 16 to both sides. 4x equals 28. We're dividing both sides by 4. X equals 7. We're not done, right? We have to find out when y is. Now, since the top one's in slope-intercept, that's going to be the one that's going to be easier to deal with, usually. Not always. And negative 21 minus 16, y equals negative 37. So these intersect at 7, negative 37. And also realize, right, my graphs usually went from negative 10 to positive 10, so I really couldn't graph that one easily, at least on the grids that I've been using, right? If you had a graphing calculator, then that would be fine. Okay, that doesn't matter which one's in slope-intercept or which one's in standard, right? This equals that y, so we can put it where that y is. That's what you're going to do. And we get 3x plus 8 equals negative 7. Subtract 8 from both sides. 3x equals negative 15, right? Negative 7 minus 8. X equals negative 5. All right, we're going to put that in the bottom one since that one's already in slope-intercept. Y equals 15 plus 8, which I believe is 23. And the solution is negative 5, 23. Right? That's way faster. Now, now I've practiced, but that's way faster than and more accurate than graphing. And when you have numbers bigger than 10 and negative 10, there's also that obstacle. So let's try this one. So you can go either way. I'm going to go 2x plus 5 equals 2x minus 4. Subtract 2x from both sides. What is that? 5 equals negative 4. What does that mean? Well, when we ever get that, that means there's no solution. But what does that mean about this system? Tell me about those lines. Hopefully you're saying, Mr. Ben, they're parallel, right? They have the same slope, but different intercepts, right? Let's try this one. All right, we're going to substitute this one in here. 3x minus 3x plus 5 equals 5. Here, we get 0 plus 5 equals 5. 5 equals 5. What does that mean? Well, that means there's infinite solutions. And what does that mean about the lines? It means it's the same line twice. And I warned you about this the other day, same line twice, right? That's the same line, the top one in slope-intercept, the bottom one in standard, right? If I add 3x to both sides here, I get the bottom equation. It's the exact same line twice, right? So those two lines are on top of each other. They're the same line twice. They hit each other infinitely. The one on the left that has no solution, those lines are parallel. All right, so let's practice. Fraction. So let's put that there. 5x plus 1/4 x minus 1/4 x minus 1 equals 20. So we could do 5 and 1/4 x, but I think I'm going to clear my fraction. So to do that, I got to multiply every term by 4, both entire sides by 4. So I get 20x plus 1x, right, minus 4 equals 80. I get 21x minus 4 equals 80. Add 4 to both sides. 21x equals 84. Oh, this comes out very nicely because 21 goes into 84 4 times. But we're not done, right? So y equals 1/4 times 4 minus 1. Those cancel. Oh, y is 0. And so it turns out these intersect at the x-intercept of both of them 40. All right, so we have two flowers. We have a daisy, we'll call that D, was 4 inches tall when it was planted and grew at a half an inch per day. We have daisy and D. Well, that'll go away, so it's fine. And we have a weed that was planted from seed. That means its y-intercept was 0 and grew at 1.5 inches. Now, you're never going to put a mixed number, right? So 1.5, right, this whole business is the same as 3/2. Yes, you could put 1.5, but I'm going to do 3/2 D. All right, write a system of linear equations to determine when the plants are the same height. All right, so when are they at the same height? When D and W, the height of the daisy and the height of the weed, are the same. So we're going to do that. We're going to substitute. And since I've got fractions, I'm going to clear my fractions by multiplying everything by 2, both entire sides. D plus 8, these cancel, equals 3D. Subtract D from both sides. 8 equals 2D. Divide by 2. 4 equals D. All right, now this is D for day. So at 4 days, but 4 days, how tall were they? Well, I'm going to put the 4 in either one. Let's do the weed just to do that, right? 2 cancels with the 4, and that equals 6. And both of them we'll see at 4. And does it say inches? Yeah, it's 6 inches after 4 days for both the weed and the daisy. All right, thanks very much. Good luck with your homework.